Hello guys, welcome back to the second lecture of our probability course. So let's start today's lecture without wasting the time. So what we learned in previous lecture. So this is the summary that we learned in previous lecture. First we know the definition. What's the probability? So we can say that it's the function that maps an event to 0, 1. Yeah, we have a set of events or we have events now. Some of might think that what's the event? Event is a subset of all sample space. Then what is the sample space? Sample space is set of all possible outcomes. So from the experiment, we are getting the set of outcomes. Yeah, the set of we are getting the outcomes. The set of all outcomes is a sample space, and the subset of a sample space is called as event. And if we are mapping an event into 0, 1, then it's called as probability. So I think now this is clear to you. Okay. Now let's move further. So our we are going to see next is okay, let me give the title. We are going to see axioms of probability. Okay, now what's the axioms? Axioms are basically the starting point. Starting point means if we in the when the probability have started at the time there are something which are predefined. There is a no proof for that. So the things that is a predefined at the starting itself, that's called as the axioms. You have to just believe it. You can't prove it. So which are the axioms? So we have here the three axioms. The first one is the probability of an event should be greater than 0, greater than and equal to 0. Then the sum of all the sample space, the probability of all the sample space is 1, and the probability this is state that the probability of a sample space is 1, and the third thing is that if A intersection B equal to 5, it means disjoint. Yeah, disjoint means there is no common between A and B. Then what we can say? We can say that P of A union B is equal to P of A plus P of B. So this is the important axioms that you have to remember because this will help us to solve the question. The first one is what the probability should be greater than or equal to 0. The probability of sample space here, let me write it is a for sample space is 1, and if A and B these are events. Here this is also a event. A union B is what? This is event. In the bracket we only write a event. Okay, so what we can say the probability of event here event is A union B, and if A and B A intersection B is 5, then P of A plus P of B. Okay, this thing you have to remember. Now from here only we are expanding this. This is for the A and B. Let's say we have a many more events. Like if we have A1, A2, A3 up to infinite. Here this we are talking about the countable infinite are disjoint events. Here we have only two disjoint events. Here we have a infinite disjoint events. Then what we can say about the probability of all the union of these events to infinite, it is the same like above. P of A1 plus A2 plus A3 like that only. Okay, this is the clear. These are just we are expanding the 3 in this way. Axiom 3 we are just expanding axiom 3. Now there is a one statement that I want to tell you what let all outcomes where from where we get outcomes from an experiment. Okay, B equally likely, then if this is the thing, all outcomes can be equally likely, then what? Then probability of A is equal to number of elements of A upon total number of sample point, means the number of events in the total sample space, or you can say the total outcomes upon, yeah, so this is nothing but the total outcomes, and this is the number of element of A. Now let's see what's the meaning of equal likely. Equally likely means, okay, first we are understanding what is the meaning of equal likely. Equal likely means S1 equal to S2 equal to S3. So each outcome has equal probability to occur up to Sn. So let's say we have S sample point. So for each sample point has a probability to occur same as the other. Okay. Now from the second axiom, we are just doing the union of three, as we know that it's one from second axiom, because I already told you the union, so the union or the sample space is one, so this is the same thing. Okay, so if, and we know that the, in the, from the first lecture we know that the property of sample space is that they are the mutually exclusive, or so we can say that disjoint. Disjoint means there is a no common intersecting point. So from the third, we can write like this. Yes. Okay. So this is the one. From where we got this? We got from the third axiom and from the property also. Property. Okay. So from here, now we know that the probability of these are all same because it's a equal likely. So we can say that n into p of s1 equal to 1. So that p of s1 equal to 1 by n. So what is this? If, what is the meaning of this? So this, the meaning of this is that if the outcomes be equal likely, then the probability of each sample point is 1 by n. Okay, you got this. Now, if you don't get, then let's understand from the example. Which example? Example of tossing a coin, tossing a dice. So, if we are talking about tossing a dice, then the outcome, or the, we can say the sample points are 1, 2, 3, 4, 5, 6. Now, for each sample point, what can be the output? So, for each sample point, the output is of getting the output is, let's say, what's the probability of getting P of 1? 1 by 6. What's the probability of getting P of 2? 1 by 6 means getting a 2. This is our event, like we want to get a 2. What is P of 3? 1 by 6. As you can see here, for all the 6 sample point, the probability is, for let all the outcomes be equal likely. Means for all the 6 point, the outcomes may be equal likely. Means you can have the same probability for all the 6 point. So for that, as you can see, what's the probability? Probability is 1 by n. N is total sample space. Now, let's prove this then. Let's say we have a event A which is getting either either 1, 2 or 3 on dice. So what's the probability? Probability from here is the number of element of A. First let's see by this. Then let's check whether we are getting the same output as this or not. Okay. So probability of getting 1, 2 and 3. So probability of getting either 1 plus either 2 plus either 3. Now we can't get both at a time. Okay, so what's the output? 3 by 6, which is the same as the number of element in A upon total sample. So as you can see, we proved this by example that if the outcomes be equal likely, then for the event this can be the probability scenario. Okay, you got it? Hmm. And like that, if it contains a k element, if A contains k element, then we can write in general form k by n. Hmm. I think this is very easy to understand. Now let's go for further, and now let's talk about the inclusion exclusion principle. Yeah, this is also very easy. Inclusion exclusion means we have to add something and we have to remove something. Okay. So for that we have, yeah, you can make it for any number of elements. Let's say if we have two event and if you want to find the union of these two, then what we can write? P of E plus P of F minus P of E intersection F. This is for any two event. Now let's prove this. How we can prove this? By using the Venn diagram. So let's say we have here the two events E, F. This is E, this is F. What's this? This is E intersection F. What is this part? This part means I am talking about only this. Let me highlight with different color also. Yeah, we have facility, then why don't we use it? So this is what? This is E minus F, or you can write as E intersection F dash. Yes, got it. Now I am talking about this part, then this is F minus E equal to F intersection E dash. F minus E means from F we are removing E. Like so this is this part and this is E, pure E, not the mixture. And this is the intersection of both. Now let's just prove. So we have LHS. So here union of these two, what we are getting? Let's say this is a, this is a B, this is a C. So union of E LHS equal to P of E union F, and that we are getting P of A plus P of B plus P of C. Now why this? Because this all these three events are disjoint. Yeah, that you can say that these all three events are disjoint. So we can write like this. Yeah, that's true. Now let's check for RHS. For RHS, we have P of E plus P of F minus P of E intersection F. Now, what is P of E? Okay, so probability of E means this full. What is P of E? P of E is P of A plus P of B means these two, summation of these two. What is P of F? P of S means this whole circle. So it is P of B plus P of C means P of B plus P of C. Now minus what is E intersection F means this only means only we are removing P of B. So what we are getting? P of A plus P of B plus P of C, which is same as LHS. So we proved this. Okay. So from here, what we can say, P of E union F is equal to P of E plus P of F minus E intersection F. Like that, you can also write for 3. Like if you have A union B union C, this thing you'll also learn in the discrete mathematics. And there you can also find a short trick to do this kind of thing for many level. means for the many events like 4, 5, 6, 7 directly. Okay, let me write it here also. Now, no, you can use there are some possibilities when we can use the trick. So P of A plus P of B plus P of C minus P of A intersection B, B intersection C, C intersection A plus P of A intersection B intersection C. That's what you can write for three events, like that four event, like that five event, all the things you can write. This is what the inclusion exclusion principle here is the proof. We have proven using the Venn diagram, and the one thing that all these three events are disjoint. This means there is a no common thing between that. Okay. Now this is the last point for today's lecture is De Morgan's law. This is same if this is applicable for the two event, then this is also applicable for the probability of the two event. So we can say that E intersection F, and we are doing a complement, which is E complement union F complement. And if we are talking about the probability of this, then probability of this, both are the same. Like that, yeah, if you want to prove, we'll prove also. You can check their proof by using the Venn diagram. Then you'll find how to prove this. And you'll also find this is a true or not. Yeah, this is the De Morgan's law. Okay, so E union F complement. If we are giving complement to this bracket, then E complement intersection F complement. I think you all know this. So we don't waste too much time on this. Now, P of E intersection F is same as 1 minus P of E intersection F complement. Means this is the total if we are removing, let's say, for these two matrix, or let's say we have just only one. This is our A, the remaining part is a complement. So if we have A complement, then we know that the range of the probability is from 0 to 1. Okay, so from 1, if we are removing this part, then what we are getting? We are getting this only. So this is the same thing. The same for the union also. What's this? 1 minus P of E union F complement. Yeah, because if you what's if you want to represent with the help of Venn diagram, so we want to find this. So what's this thing? This thing is that E intersection F complement means the other part. Okay, let me other part, and you remove the other part from one, then you'll get this point. And the same E union F means this. From all the part, remove other part, then you will get this part. This is very easy to understand. Okay, now let's see one question which I put here. Okay, let me find that question. So yeah, this is the question which we have. Okay, what's the question states that the probability that the rain will today is 0.5. So let's write probability of RT means rain today 0.5. Probability that rain tomorrow. Probability of RO. Let me write RTO. Rain tomorrow is 0.6. The probability that rain either today or tomorrow means probability of RT union RTO means either today, either tomorrow. Okay, what's the probability that the rain will today and tomorrow? This is given 0.7. What is the probability rain today and tomorrow? Okay, So we know that inclusion exclusion principle. From that we can find this how. We know that this for union of two event is equal to P of RT union RTO is equal to P of RT plus P of RTO minus this, let's say X. X, now we just want to find the X. So zero point 0.7 equal to 1.1 minus X. So what's the value of X? X is zero point 0.4. So this is our answer. This is a very easy example. You can do it with the help of inclusion exclusion principle. Now, okay, let me copy this and put it in a place so that, okay, don't do the changes here. Let easy then. What's happening, bro? Okay, now let's do for the this question. We have P of A intersection B, P of A complement B complement, then we want to find A union B. So first find A union B means P of A plus P of B minus P of A intersection B. We know that. What we know that P of A plus P of A complement equal to 1. So we have given P of A complement. So from that we can find P of A. Yeah, we can find P of A. So let's write it 1 minus P of A complement plus 1 minus P of B complement minus 1 by 2. 1 minus A complement 1 by 3 plus 1 minus B complement also 1 by 3 minus 1 by 2. Let's do 1 1 2 minus 2 by 3 minus 1 by 2. Let's take the LCM. So this will be a 6. 6 means 12 minus 6 means 4. And here we have to multiply by 3 minus 3 by 6. So if we are removing 5 by 6, which is same as 10 by 12, because we have to check for the option. So this is option B. Yeah, this is what we learned today. We learned inclusion exclusion principle. We saw inclusion exclusion principle. Okay, this is the main statement that will be used in the question solving. Then we saw what is if the all the likely equally likely to occur. Then this is very useful directly. Axioms of the probability, first, second, and the third. Okay, so this is the thing which you learned today. If you have any problem, then just ask me in the DM. And the last is De Morgan's law. So if you like this video, then do like, share with your friends, and do comment if you find any problem. Thank you guys.